Hi and welcome to a brief tutorial on SAP HANA. So in this tutorial we're going to look at an overview of what SAP HANA is. We're going to look at some of the features of SAP HANA and why is it considered better than other databases. We're going to also look at the architecture of HANA and where it fits in the overall business scenario. And then we're going to look in depth into the Eclipse based HANA Studio, which is the application design tool of HANA to create information models. These information models will be used in the reporting layers to analyze complex data. So what is SAP HANA? SAP HANA first and foremost is an in-memory database. So that means that most of the data computations are done in memory instead of reading from the disk as in any other regular databases. So it's also a platform and it can be offered as an appliance or a cloud offering because it has an embedded application server in it, which is used for control flow logic, and because of that it's not just a database, it can also be called a platform. And then it also has a web server attached to it, which can be accessed via HTTP. So you can use HANA as an application in and by itself. So let's move forward and look at some of the features of SAP HANA. So the first feature, as I mentioned, is it's an in-memory database. All operations, read and write, happen in memory. And then the next one is column stores. Unlike in regular databases, the data in HANA is stored in columns. So this actually enables massive data compression, partitioning, and secondary indexes. Usually in regular databases, we have to go ahead and create secondary indexes, but because we use column stores in HANA, it already serves the purpose of secondary indexing. And then the next one is parallelism. So what is parallelism? How in HANA? It means that the different CPUs process data in parallel, thereby saving a lot of time and space, and really increases the performance. And then we have the other feature as projections. Projections is nothing but we choose only the data we need, or only the data we need to analyze. So we don't have to bring up all the data, because we have in memory, it's an in-memory database, and you can perform operations in memory and get really good performance. So you can only choose whatever data you really need. Then comes the dynamic aggregation, which means that we don't have to have any aggregates on them. So what does it really mean? So in BW and other applications, we have to compute the totals and store them in aggregates. So what happens is you have to spend a lot of time filling those aggregates, and a lot of space which requires to store the data in aggregates. So we don't have to do all that in HANA, because you can do dynamic aggregation, so you can do totals on the fly because of the high performance of this HANA database. So that's what it means by dynamic aggregation. So the next is active and passive storage. So what it really means is you only use the data which is active, like for current year, data can be in active mode, and the rest can be stored as in it's also called a cold storage. So you don't have to have all the data in memory. You only need to have data which is used mostly, like as I said, current year or current fiscal year. Only that data can be put in memory and used for computations. Then we have real-time analysis because of SLT, which is SAP landscape transformation, which is the table-to-table mapping in HANA, which enables us real-time analysis. And then we have SQL script, which can perform really complex calculations, and you can analyze data in a very complex way because we can use SQL script. So there are many other advantages of HANA as a database. It is the database SAP has come up with. And it has been built from scratch. So which means that you don't have to build on whatever is there. So since you're doing it from scratch, we have this column stores and parallelism and in-memory database, whereas the regular databases operate on row storage and reading from the disk, and not that much parallelism. So because it's built from scratch, they enabled and they incorporated all these beautiful features which really enhance the performance of HANA. So moving forward, let's go and look at what how HANA architecture looks like. So if you see the diagram here, this is basic HANA architecture. So here we see that we get data from the different systems, the SAP Business Suite, the SAP NetWeaver BW, third party. So we get all the data and incorporate it into the SAP HANA. And then we use reporting tools like SAP Business Objects, which is the official reporting tool of HANA, and then other applications will use the information models created on SAP HANA to have complex analyzing of data in the reporting layers. So as you see in the SAP HANA, you see that you have the in-memory computing engine, you have the modeling studio, which we will be looking at briefly shortly. And then we have real-time replication services, which I have mentioned about. We're going to look a little bit into the different methods of how we can get data from different databases into SAP. And then we see that we have the calculation and planning engine to perform the calculations, and data services is another way of transferring data from other databases to SAP HANA. So this is a basic architecture diagram of HANA. So basically what we're saying is we bring data from other databases into SAP HANA, which is which is a inbuilt application in and by itself. It has you can transform data and put it into SAP HANA. You have the application server, and the main feature of SAP HANA is most of the data computations are done in the database itself. You don't have to bring it to the application layer and do the computations there and send the data back into the database. Everything is done in the database, so that saves a lot of time, that saves a lot of storage, because you don't have to bring the data every time to the application server, every time you have to do a computation. So this is a very wonderful database. And so yeah, once you have the data in the database or in HANA, you have an ability to perform very complex analysis of business information using the reporting tools. So as I've mentioned before about how we need to get data from the database into the application layer, perform all the data intensive logic there, and bring it back to the database in a regular database, versus in HANA where you have the access engine, which is the application server, and it has this small layer compared to the database, because most of the database logic or the data intensive logic is done in the database, and we need a very small layer for a control flow logic. That's why the application layer in HANA is called access engine, also an extra small engine. The other name for it is extended services. So we need a very small layer for control flow logic in HANA. So that's why, and since the application layer is embedded in HANA, it understands the language of the database very much better than having another application layer physically put on top of your database. So what I really mean is the application server in HANA knows the database, the HANA database and the data types so well that it communicates better than if you have a regular database and you have to have a application layer bought on top of it. So that's the main advantage of HANA, because it better communicates. The application server of HANA, which is the Access application server, communicates better with the database. So moving forward, we'll see what SAP native HANA is. So this is the same as what we have discussed so far. So native HANA is nothing but you bring data into HANA from different sources and then build models, information models on SAP HANA, and then use them in reporting tools. So you're basically using the application server and web server of HANA for your application. So this is just an overview. We'll see a little bit more in detail in the later slides. So as you can see here, this is the native HANA XS, which is the extra small or extended services infrastructure. So as we can see, the database, the calculation logic is done in the database here, and then the control flow logic is done in the XS application layer, and the presentation logic is usually done in the client because of the way modern laptops and smartphones work. Most of the presentation logic can be done on the client devices, whereas the control flow logic, which is a very small layer, as I have said before, can be done in the XS application layer. So then if we move forward, this is like a little bit of detail into the SAP native HANA architecture. So as we can see here, we have different systems: SAP, non-SAP, and then the flat file. The flat files which are supported in HANA are the XLS and the CSV. So and yeah, we'll be looking at how to load CSV files shortly. So we get all the data from these systems into HANA using one of the transfer methods here. So SLT is nothing but the SAP landscape transformation. What it really does, it's a table to table mapping. So whatever tables are in a database, it maps one to one into the HANA database. So then we have the business objects data services. So this data services, we use this data services to transfer data as well. And then we have the DXC, which is the direct transfer, direct extract transformation, which is nothing but in SAP we have SAP delivered data sources, which are a replica of the database tables. So it's basically a structure where you can transfer data from SAP ECC to BW. So we are using those data sources to transfer data from the SAP systems into the HANA database. And then as you can see here, we build information models in HANA using the HANA Studio. And then the information models reside in HANA, and then we use those models in our BO and other reporting tools. And as I've said, BO is the official reporting tool of HANA. So this is a little bit of detail as to how HANA works. So this is basically what we do from end to end in SAP HANA. So this is native HANA. So what is non-native HANA? Non-native HANA is nothing but it uses the data intensive logic and this application server logic from HANA, but they also have another application server like ABAP or .NET or Java located outside of HANA, and they connect to these application servers by using open standard interfaces like ODBC and JDBC. So I put together a slide which shows us the different ways to upload data to HANA. So the first one, as I mentioned earlier, is SAP landscape transformation, which is a table to table and real time. And then it's the business objects, business objects data services. And then it's the DXC, which is the direct extractor connection, which uses the standard data sources of SAP, which it used to transfer data from ECC to BW. So we use those data sources to extract data from other systems into HANA. And then, as I mentioned, flat file is CSV or XLS. Moving forward, let's look at the advantages of SAP HANA Extended Services application layer. So mainly it's used to broaden the implementation base. So instead of just the database, we have the application server, so which is an added advantage. And then it enables application development, and then it also enables HTTP based user interface, and then better performing applications due to, as I've mentioned, deeper integration with database itself. And then it runs on SAP HANA, which is a very good database, and then we don't need any external application server unless we have something up and running and we want to connect it. We don't really need another application server to have an end-to-end application. So moving on, I have a small slide on BW on HANA. So what it means is it's a non-native application. So how it works is here we can see that Oracle is connected to BW in an original scenario, and what we do is we transform the Oracle database into SAP HANA using one of the different methods we discussed before, and then we upgrade BW to whatever the current version is, or whatever version works on HANA, and then we connect the SAP HANA to BW. So all your models will be, your BW models will be there, but you're just using the HANA database, which is a much better database than the regular databases, and you connect that HANA to BW, and you still use your BW as well for your modeling and reporting purposes. So this is a small scenario for non-native HANA. So moving forward, we have the SAP HANA Studio. So what is SAP HANA Studio? So it is an Eclipse based application development tool in HANA. So here is where we go and develop the information models. We have different perspectives here. Perspectives are nothing but roles. So we have the modeler perspective, developer perspective, administrative perspective, debugger perspective. So according to whatever tasks you're performing, you go into one of these perspectives. There are a whole list of other perspectives as well, but in this tutorial we'll be mainly dealing with the modeler perspective and create different information models in HANA. So as I've mentioned, it's an Eclipse based tool, but we have also some plugins added into the Eclipse based tool to perform in a way we want HANA Studio to perform, and we won't be discussing that very much, but if you go into the development perspective, that's where we see the functionality of the plugins in HANA Studio. So in the HANA Studio, we will be designing an attribute view, analytic view, and calculation view. But before that, we're going to also create some tables and load some data from a CSV file into those tables, and then use those table data in our information models. So that's what we're going to do in this tutorial. So once you log into the system, like I did, I went to my Eclipse shortcut after installing the Eclipse based HANA Studio. You click on it, and this is the studio. This is how the studio looks like. I actually have my modeler perspective open. If not, you can just go ahead and click on the small button here and add your perspectives. You have a whole list of roles or perspectives which you can log into and work on it. So in our tutorial, we'll be only working in the modeler perspective. So once you log into the modeler perspective, so these are all the so this is my system here. So how I got connected to that system is there's this small icon here which says add cloud